In this video, we are going to sketch reciprocal graphs. When we have a reciprocal graph, we get asymptotes. They are lines that the graph gets closer and closer to, but never touch. And they happen when we have an undefined value. So if we tried to substitute 0 in for x, we wouldn't be able to get out an answer for y. So there's an input for x that doesn't have an output. So that just causes a line that the graph never touches. So let's have a look at what this graph looks like. So it's y equals 2 over x. So when we have a really big number in for x, we get out a really small answer for y. So the bigger x gets, the smaller y gets. And if we put a tiny answer in, a tiny number in for x, like 0.00 something, we'll get a really big answer out. So it's never going to reach the x-axis. It's going to get closer and closer to it. And it's never going to reach the y-axis, but it's going to get closer and closer to it. So that's for positive values of x. If we put in a negative for x, we'll get out a negative for y. So the graph repeats. When x is negative, y is negative as well. So that's a positive reciprocal graph. It's in the bottom left and the top right. For a negative reciprocal graph, if we put in a negative for x, we'd get out a positive. And if we put in a positive, we'll get out a negative. So it's in the other two quadrants. It's in the top left and the bottom right. And again, it's the same shape. So it's never going to touch the axis. It gets closer and closer to it, but never touches it. And it's the same in the other. Have a go at sketching the graph of y equals 4 over x. Pause the video and give it a go. So the graph of y equals 4 over x is pretty much the same as 2 over x. It'll be a bit higher. It'll be twice as high. So all of your y values will be twice as big for the same x value. It'll be twice as high, but it'll be the same shape. So it can't equal 0. So you can't have an x is 0. There'll be nothing for x is 0. And there'll be no answer, nothing, no input that makes y 0. So it's undefined as an asymptote there. So it's exactly the same shape. As the previous graph. And for y equals negative 4 over x, it's going to be in the top left and the bottom right. So the negative ones are in the top left and the bottom right. The positive ones in the bottom left and the top right. Here we have y equals 2 over x squared. So x is squared this time. We still can't have an input of 0. So that would be, it would get no answer. So you still can't have 0 as an input. So there's still going to be an asymptote at 0. And there's still nothing you can put in that would give an output of 0. You can get really, really close to it by putting in bigger and bigger numbers, but you can never reach it. So these graphs are pretty much the same as the previous ones. The only difference is if you put in a negative, you're going to get out a positive. When x is negative over this side, the y's are positive. So it's a symmetrical. It's like a reflection over the y-axis. The negative one. So if you put in a positive or a negative, you're going to get out a negative answer. So you're always going to get out a negative answer and it's going to have the same shape. So if you put in a positive, you get out a negative. And if you put in a negative, you get out a negative as well. And again, 2 for you to sketch. Give them a go. So the only difference between 2 over x squared and 4 over x squared is the 4 graph is just going to be above the 2 graph. It's going to be slightly higher up. But apart from that, the shape is exactly the same. And the negative graph, no matter what input you have, a positive or a negative input for x, you're always going to get a negative out. Okay, on the same diagram, sketch the graphs of y equals 4 over x and y equals negative 4 over x. So I'll use different colors for them, otherwise it would be very confusing. So y equals 4 over x, I'll do in green. So it's in the bottom left and the top right. If you put a positive in for x, you get a positive answer out. And it's the same shape. It can never be equal to 0 on the x or the y-axis. And if you put a negative in, you get a negative out. For y equals negative 4 over x, if you put in a negative, you get out a positive. So when x is negative, y is positive. And if you put in a positive, you get out a negative. Have a go at this one. So for 2 over x squared, if you put in a positive or a negative for x, you're going to get out a positive answer because you're going to be squaring it. So we have this shape. It can never equal 0. And for negative 2 over x squared, if you put in a positive or a negative for x, you're going to get out a negative answer. So this graph is in the bottom two. On the same diagram, sketch the graphs of y equal negative 1 over x and negative 3 over x. So we're going to have two graphs. One's going to be just above the other graph. So let's do the negative 1 over x. There's a negative graph. If you put in a negative, you get out a positive. So it's in the top left, and it's in the bottom right. If you put in a positive, you get out a negative. Minus 3 over x is going to be the same graph, just 3 times as high. So every answer, every output, every y value will just be 3 times as much as the other graph. So it's the same graph, and it's just above it. One for you to try, so give this one a go. So on the same diagram, sketch the graphs of y equals 2 over x squared and y equals 3 over x squared. So 2 over x squared. So for inputs that are positive or negative, you're going to get out a positive answer. So it's here and here. 3 over x squared is going to be above 2 over x squared. So it's here and here.